We're looking at Chapter 4 on the sample exam, Rational Expressions and Equations. In this unit, we looked at simplifying rational expressions, we looked at adding and subtracting rational expressions. We multiplied and divided rational expressions. We solved rational equations. And with all of this, we had to keep in mind our NPVs, the non-permissible values. So let's look at multiple choice number 16. Once again, you may want to pause the clip at each question and attempt it on your own before I do the solution. What are the non-permissible values for the rational expression 3x over 5 times 4 subtract x times 2x plus 1? And what NPVs are is anything in the denominator that would make the expression in the denominator equal to 0. So we take each one of the factors and determine the value for x that would make it equal to 0. Of course, 4 cannot equal x, or x cannot equal 4. And here, 2x plus 1 cannot equal 0. 2x plus 1 cannot equal 0. So 2x cannot equal negative 1, and x cannot equal negative 1/2. And so that's our non-permissible values, since these values is what, when we substitute them in for x, would make the denominator 0. And when the denominator of a fraction is 0, it's undefined. What is the simplified form of x squared over x squared subtract 5x? And when we simplify, first we must factor. And here in this unit, you have to have the skills of factoring binomials. So we have x squared over x outside of x subtract 5. And we took out a common factor of x here, and that's one of the types of binomials that we need to know how to factor in this unit. And when we have to cancel any common factors, and there's a common factor here of x. And so when I cancel x with x squared, I'm still having x up here in the numerator. That will give us x over x subtract 5. Let's see. What expression is equivalent to? And we talked about this in 4.1, talk about equivalent expressions. When expressions are equivalent, they must be simplified to be the same, and also have, more importantly, also have the same NPVs. So they must have the same NPVs, and they must simplify to be the same expression. Simplify to be the same expression. And so here, when we look at this one, we have, here in A, we could factor it as binomials again. And there's a common factor of x in both, x outside of x subtract 5, over x outside of x plus 5, x subtract 4. And then the common factor of x could be canceled. But yet, when we do our NPVs, this here has an NPV of both 4 and 0, so because of that x on the outside here. And so that A and are simplified in this equation we're referring to up here do not have the same NPVs, so they cannot be equivalent expressions. In B, we can factor here. There's a common factor of 2x plus 5 over x subtract 4. It doesn't simplify to give us the same expression. So B is not equivalent. In C, it's a common error that happens here. You see how 3 is multiplied by x in the numerator and 3 is multiplied by x in the denominator. But in order for the expressions to be equivalent, you must multiply both terms by that constant, not just the first term or not just the second term. And here you can see, I mean, the NPVs are not the same as the NPV here will give us 3/4. Let's look at D. By process of elimination, it must be the answer. We have 5 outside of x plus 5. That's a common factor. And we have in the denominator 5 outside of x subtract 4. So we can cancel out the common factor of 5, and the NPV here will be 4. And so D will be the answer since its solution is the same as when it's simplified, and the NPVs are also the same. So we're simplifying here, and simplifying is in section 4.2. And to simplify, you need to be required to know how to factor binomials. In the numerator, we have a common factor of 4. 4 outside of 3 subtract x all over. In the denominator, we have a common factor of 2. 2 outside of x squared subtract 9. Yet we're not finished just yet, because here is the other type of binomial that we are required to know how to factor in this chapter. Right here we have a difference of 2 perfect squares. And so that can be factored to be, we'll keep the numerator the same because that's factored completely already. That would be 2 outside x plus 3, x subtract 3. So when we have a difference of 2 perfect squares, if you recall, you have to take the square root of the first, which is x, and the square root of the second term, which would be 3, and it's plus and minus. And here we now would cancel any common factors. When we cancel the common factors, 2 is a common factor here, and we're left with 2 in the numerator rather. We also cancel here. X subtract 3 and 3 subtract x are what we call opposite factors. Since the sign, this is a negative x and this is a positive x, this is a negative 3 and this is a positive 3. Since both terms have the opposite signs, we could say they cancel to be -1, not 1. And so that will give us -2 over x plus 3. So here we have to simplify again, but it's division. And that was in section 4.4, dividing, multiplying and dividing rational expressions. So we would factor first if there's anything to factor. We have all monomials here, so there is nothing to factor. We have x over 9. When we're dividing rational expressions, we multiply by the reciprocal. And now we can cancel any common factors, and there will be a few here. X can cancel, and that would leave x squared on the bottom in the denominator. And so if you look at the answers, there's only one that has an x squared in the denominator, and that would be A. But let's continue. We have 9, 3, there's a common factor of 3 here. 3 goes into 3 once, and 3 goes into 9 3 times. And there's also a common factor of 2 left in the 6 and the 4. And so we have 2 goes into that 3 times, and 2 goes into 4 twice. Once again, there's still one more common factor left in the numerator and denominator, and we have 3 and 3, which makes 1. And so this will give us 1 over 2x squared. We have the 1 here over the 2x squared right here. Here we have 4.4 actually. The division and multiplication was 4.3. This is adding and subtracting rational expressions. And when we have to add and subtract rational expressions, as with adding and subtracting rational numbers, you must have a common denominator. So first we'll factor if possible, and the denominator of the second expression can be factored. That's 2 outside of x plus 3. Making the lowest common denominator here 2 outside of x plus 3. And so we will have something over 2 outside of x plus 3 subtract 5x over 2 outside of x plus 3. Now the question is, what will you multiply x plus 3 by in order to get 2 outside of x plus 3? And the answer here is you must have multiplied it by 2. So we must have multiplied this by 2, so we must multiply our numerator by 2 as well. So that will give us 4x. And here we have 4x subtract 5x will give us negative x over 2 outside of x plus 3. They all have the same non-permissible values, and so we can just say that our answer would be C. The constructed response item, we have simplify and state restrictions. So our simplify here is division. Let's factor first, and in our first expression to factor right here will be a difference of 2 squares. That's 1, which is a perfect square, and x squared, which is a perfect square, and we have a difference. So that's a difference of 2 perfect squares. When we factor that, we have 1 subtract x times 1 plus x. In the denominator here, we have a binomial where there's a common factor of 8. So we take the 8 outside. We have 1 subtract x left inside. And that's divided by the numerator. There's a common factor of 3. So we have 3 outside x plus 1 all over, and the denominator in the second expression is already factored for us. Now we can cancel any factors, common factors in the numerator and denominator. First I'm going to change the division to multiplication. So I'll have 1 subtract x, 1 plus x, over 8 outside of 1 subtract x, multiplied by, and there's a reciprocal here. So we have to multiply by the reciprocal. So now 2 outside of 3x subtract 1 is in the numerator, and 3 outside of x plus 1 is in the denominator. Now we can cancel any factors, common factors, in the numerator and denominator. And we have, here's a common factor, and we have a common factor right here, and we have a common factor of 2 here into an 8. And that will give us 3x subtract 1 over 12. It also says simplify and state any restrictions. So there is some NPVs here. We have to be careful. NPVs, once again, are anything that would make the denominator of an expression 0. And so we have, this has been in denominator, so this will be part of the NPVs. And that will give us 1 subtract x cannot equal 0, so 1 cannot equal x, so 1 is an NPV. We also have an NPV right here that's been in the denominator, and that will give us 3x subtract 1 cannot equal 0, so 3x cannot equal 1, x cannot equal 1/3. So we have another NPV. And then when we change division to multiplication, we add the third NPV. Since this goes into the denominator now, we have x plus 1 cannot equal 0, so x cannot equal -1. So our NPVs, our restrictions are -1, 1/3, and 1. So be very careful when you're dividing rational numbers that when we multiply by the reciprocal, both the numerator and the denominator in the second expression will be part of the NPVs. Pat and Chris can paint a house in 4 hours if they work together. Pat is a professional painter and can work twice as fast as Chris. How long would it take for Pat to paint the house himself? And so here's the word problem. We have Pat and we have Chris. We have Pat and Chris, and then they work together. And so Pat is a professional painter and can work twice as fast as Chris. So if Pat is a professional painter and he works X amount, Chris is twice it takes Chris 2 times as long to complete it. So a common mistake here is to put Chris as X and Pat as 2X because it says that it's twice Chris, but that would make him longer. That would make Pat longer. I mean, another option here could be Chris could be X and Pat would be X over 2. Together, they are 5 hours. So in how much can Pat do in 1 hour? Pat can do X 1X, and Chris can do 1 over 2X. And together in 1 hour, they can do 1/5. So one rational expression would be 1 over X plus, that's Pat, plus Chris, 1 over 2X will equal 1/5. Another option is that, and some of you may have set it up this way, where you had, this would be 5 over X and 5 over 2X, and together they do a one full house. And so another option would be 5 over X plus 5 over 2X, which equals 1. And so I will continue with the first one, and then we'll do the second. 1 over X plus 1 over 2X equals 1/5. And so we have to determine the LCD. The LCD in this case would be 10X. Since I can, if I multiply X by 10, I'll get 10X. If I multiply 2X by 5, I'll get 10X. And if I multiply 5 by 2X, I'll get 10X. So now I'll multiply every term in the equation by the lowest common denominator. So that'd be 10X times 1 over X plus 10X times 1 over 2X equals 10X times 1/5. And now we're multiplying by the lowest common denominator so that we can eliminate the fractions, so that we can get rid of the fractions. And it's not to put everything, to rewrite every fraction using the lowest common denominator, is to multiply each term by the lowest common denominator so we can remove the fractions. And here you could see that if we continue, at 10X, there's a common factor here of X, so we can cancel the common factor of X. And we get 10 times 1, which is 10, plus there's a common factor here of X and also of 2, which will leave 5, so we just have 5 times 1, which will equal, there's a common factor here of 5, which will leave 2X. And so 15, which equal 2X, 15 over 2 equal X. And that's Pat. Pat is 7.5 hours. We could also look over here on the next one. We have to find the LCD. The LCD here will be 2X, and so we do the same. We still multiply each term of the equation by 2X. And we cancel out common factors again. The common factor here of X is of X, so that's going to be 2 times 5, which is 10. Plus there's a common factor here of 2X, so it's just going to be 1 times 5, which is going to be 5. And here 2X times 1 is 2X, and you see we're back to here again. It's going to be 15 equals 2X. 15 over 2 equals X, which is the same, of course, what we had before. Another option here is that this could end up where we have a quadratic. Our resulting equation here was a linear equation, and so we only had one possible answer. This could also turn out to be a quadratic, in which we have to solve either by factoring, of course that's more convenient if it's factorable, or the quadratic formula. When that happens, one of the values, when you solve the quadratic, one of the values would have to be rejected. It wouldn't work for the context of the problem. And so 16 to 21 on the multiple choice section of the public exam will be from Rational Expressions and Equations, Chapter 4. The constructive response questions will be number 54 for Chapter 4. The word problem will most likely be there where you have Pat and Chris painting a house and trying to determine how long it takes one or how long it takes both of them. It is likely it will be an A and B scenario, the same as here, where A would be either adding and subtracting rational expressions or multiplying and dividing, and B would ask you to solve the word problem.